for us to take a look at here. There we are, almost to the top. And with this one, we've got Connelly Manufacturing. They make ice cream makers, and they've got some steady growth. And since her business has grown, Jan Delaney, the president, believes she needs an aggressive advertising campaign to maintain growth. To prepare for growth, they put together some data for the current year, some variable cost per ice cream maker. Variable cost includes some labor, materials, and overhead. Some fixed cost, which includes manufacturing, selling, and administrative cost. Total fixed cost, selling price per unit 67. They expect to sell 30,000 units, and they expect to spend additionally $200,000 worth of advertising. And so we've got several questions here based on that. Question 1, cost and sales price remain the same. What's the profit for the year? What's the break even for the year? If Jan has a sales target of 35,000 makers and she thinks she can achieve that by an additional fixed selling expense of $200,000, should she do that, and so on. So let's just go through each scenario and see if we can understand them. So for the first one, basically, what will they make now? And so the formula is simply sales minus variable cost minus fixed cost gives me what she would expect to make. And the Excel formula, you can see, is right here. And D20, and D20 is basically my sales, and then times D19 minus D13, which is my selling price per unit minus my variable cost per unit of 34. So basically, what's my margin per unit? And then minus D18 of my fixed cost. And so that formula then gives me my sales minus total variable cost minus my fixed cost. My variable cost is 30,000 units times $34, and that gives me a gross profit of $509,500. My break even in units then is right here. My break even is basically, do you take your $67 of your sales price, and it says it equals 34Q plus 480, and 34Q being my variable cost. You can see my break even in units is the 14,561. Let's do the formula here, and let me show you that. D18, let's go up to that. D18, which is my total fixed cost, divided by D19 minus D13, which is my selling price per unit minus my variable cost. So basically, if I know that my fixed costs are $480,500, how many units do I have to sell to cover my fixed cost? And the answer is basically my sales price of 67 minus my variable cost of 34. So it's basically $33 is my contribution every time I sell a product. I've got $33 worth of contribution margin to pay for my fixed cost. And so it turns out to be the fixed cost of $480,500 divided by 33, and I get the answer, which is the 14,561. So if I sell that many units, I break even. And the next one is what happens if she adds to her fixed cost, and will she be able to, how much money will she make if she can sell 35,000 units? And the question then really is, should she do that, yes or no? And so you can see the formula right here. You can see it right here, but you can see it in Excel right here. So she's taking 35,000 units times her sales of 67 minus her variable cost of 34 to get $33 worth of contribution margin minus D18, which is her fixed cost, minus $200,000. And so she's basically added to her fixed cost by $200,000 and sold 5,000 more units. But the issue is that additional 5,000 units did not contribute enough to pay for the additional fixed cost of $200,000. And so she's actually going to lose money if she does that. She's going to make less money than by doing, basically by doing nothing, by just doing what she's currently doing. Question 4 then becomes, what's the break-even in units if she does that? So the break-even in units if she does that becomes her fixed costs now go up by $200,000. it go from 480,500 to 680,500. And so just think of it this way, that 680,500 divided by her contribution margin, which is the sales price of 67 minus the variable cost of 34, which is $33. So 680,500 divided by 33 means she has to sell more units to break even. So by doing this, if she were to go that route, she has to sell more units to break even, and she's going to make less money. And then question 5 is, if the additional $200,000 is spent for advertising the next year, how many more sales in units does equals the current year's income at 30,000 units? And so you can see what that turns out to be right here with this formula. And I should break that out just a little bit more. And so you can see that how that turns out. 509,500 is basically her base profitability, equals 67Q, which is her sales price, minus her $34 variable cost, minus her new fixed cost of 680,500. So she'd have to sell 36,000 units to sell at least have the same profitability as 35,000 units. So she's got to sell 1,061 more units than 35,000 to maintain the same level of profitability. And then question 4, part 4, to do a contribution margin income statement. And so that is basically just taking your sales minus variable cost to get down to your gross margins. Remember that sales minus variable cost is your gross margin. That gives you your your contribution margin. Let me say that right. Minus your fixed cost to get down to your profit. So this basically proves her. This is her contribution margin income statement. Her sales revenue at D19 times I50, which is her break even using the additional extra sales, $200,000 worth of sales. So it basically tells her how much more she has to sell to break even with the new increased advertising cost. And so this kind of gives you a feel for proving the number. Percentage increase in fixed cost is 41%, and then her break even goes up almost the same number, just a little bit of rounding there. And then 9-22, with 9-22, we've got some merchandise, general merchandise store in rural Virginia. Harold sells appliances, clothing, auto parts, and farming equipment, among a wide variety of other types of merchandise. Because of normal seasonal and cyclical fluctuations, he knows his business will have these fluctuations. He's planning a CVP analysis, basically how much he would expect profits to change based on some information. So we want to figure out what his break-even is and his margin of safety and a few things like that. So first is to calculate his break-even point. So his contribution margin ratio, using the contribution margin ratio, and his break-even point then is the contribution margin of 227,500 divided by his sales price, or basically his revenues, I should say, of 650, gives 35%. Then his break-even is $105,000 of operating cost divided by that 35% gives him a break-even in dollars of $300,000. And so therefore his margin of safety is his sales price of 650 minus his break-even of 300, and that's 350. So that's a pretty good sized margin of safety, and expressed as a ratio is just the 350 margin of safety divided by sales. And he's got a very healthy margin of safety. So basically his sales could drop by 53%, and he'd at least break even. He wouldn't lose money. And then for question number 2, what's the significance of those measures? It's basically, it helps him measure his risk. How much could sales fall before he would lose money? And so what if Harold's margin of safety and operating profit, if sales were to fall to 500,000, and he's still in pretty good shape if sales fall a little bit. He's really not going to be in too bad a shape. If sales fall to 500,000, the break-even point stays the same, of course, that doesn't change, but the margin of safety would change. It'd become 200,000, and you can see it right here. And his contribution margin would be 175, his fixed cost would be 105, he'd still have a profit at that level of $70,000. So he's in pretty good shape. And then for 9-26, we've got some operating leverage here to calculate. And you can see that we've got two companies, A and B, and we've got their information in terms of their sales, variable cost, contribution margin, and fixed income. And it says to calculate the degree of operating leverage for each company, if sales increase, which one benefits more? And then assume that sales rise and so on. So basically, to compute this, it's not too hard to figure out. It's basically their D9 minus D11, or divided by D11. It's basically the contribution margin divided by their operating income. And you can see for A and B, they're very different. And what that means, if sales increase, for B will benefit more because they've got the higher degree of leverage. And because more there has a higher proportion of fixed costs in relation to variable cost than A. So basically that just tells you if sales go up, at what level will the bottom line change based on that. Okay, and that's really how that one works.